Hello everyone. Welcome back to my channel where we dive into solving challenging coding problems today. We are going to tackle the number of paths with max score problem from LeetCode, which is classified as a hard problem. But don't worry, by the end of this video, you will have a clear understanding of how to approach this problem and how the solution works. The problem requires us to find the maximum score we can achieve by moving from the bottom right cell to the top left cell in a grid, where each cell can contain a numeric value, the letter X, or the letters S or E, which represent the start and end points, respectively. We can move in three directions: up, left, or up left. The goal is to maximize the sum of the numeric values we visit and count the number of paths that achieve this maximum score. So, what's the core insight here? Well, imagine you're trying to get from the bottom right corner of a maze to the top left corner, and you want to collect as many coins as possible along the way. The coins are represented by the numeric values in the grid. You can move up, left, or diagonally up left, but you need to avoid obstacles, which are represented by the letter X. This problem is all about finding the optimal path that maximizes the number of coins we collect while navigating through the maze. The key intuition here is that we can use dynamic programming to build up a solution by breaking down the problem into smaller subproblems and solving each one only once. Let's think about how we can approach this problem. We start at the bottom right corner, which is the start point S, and we want to reach the top left corner, which is the end point E. We can move in three directions: up, left, or up left. At each cell, we need to decide which direction to move in order to maximize the sum of the numeric values we visit. We also need to count the number of paths that achieve this maximum score. This is where dynamic programming comes in. We can use a table to store the maximum score in the number of paths for each cell, and then build up the solution by filling in this table. Now, let's take a look at the C++ code that implements this solution. We start by initializing a 3D DP table called DP with dimensions nx and nx2, where n is the size of the grid. The first dimension represents the rows, the second dimension represents the columns, and the third dimension represents the maximum score and the number of paths for each cell. We initialize the DP table by setting the value of the bottom right cell to the numeric value of the cell if it's not the start point S, and to 0 if it's the start point. We also set the count of paths to 1 for the bottom right cell. Then, we iterate over the grid in a bottom-up manner, starting from the second to last row and column. For each cell, we check if it's an obstacle or the endpoint E. If it's an obstacle, we set the count of paths to 0. If it's the endpoint E, we set the maximum score to 0. Then, we consider moving up, left, or up left from the current cell, and we update the maximum score and the count of paths accordingly. We use a temporary variable called max score and count to store the maximum score and the count of paths for the current cell, and then we update the DP table with these values. Finally, we return the maximum score and the count of paths at the top left cell. So, what's the time and space complexity of this solution? The time complexity is O(n squared), where n is the size of the grid. This is because we iterate over the grid once, and for each cell, we consider three possible moves: up, left, and up left. The space complexity is also O(n squared), which is the size of the DP table. That's it for today's video on the number of paths with max score problem. I hope you now have a clear understanding of how to approach this problem and how the solution works. If you found this video helpful, please like the video, subscribe, and comment your approach below. Don't forget to hit that notification bell to stay up to date with my latest videos. Thanks for watching. And I'll see you in the next video.